Today we're going to be talking about inequalities in triangles. The first theorem that we have is the triangle inequality theorem, and that says that the sum of the lengths of any two sides of a triangle has to be greater than the length of the third side. So what that means is that xz plus zy has to be greater than the third side, which is xy. xy plus xz has to be greater than zy. And then our last one is zy plus xy has to be greater than xz. So some examples involving that. Is it possible for a triangle to have sides with each of the lengths indicated? So take and add two sides together. 10 plus 9, is that greater than 8? Yes, that works out. Take 9 plus 8, is that greater than 10? Yes, that is true. And then our last one, 10 plus 8, that is greater than 9, so that is also true. So yes, this can be a triangle. B, 6 plus 6, is that greater than 20? Well, 6 plus 6 is 12. That is not greater than 20, so no, that cannot be a triangle. 8 plus 4, is that greater than 12? Well, 8 plus 4 is 12. 12 is not greater than 12. Notice how there's no equal to sign. So therefore, this also cannot be the lengths of a triangle. Example 2. Two sides of a triangle have lengths of 15 and 20. Write an inequality for the possible lengths of the third side. So x is going to stand for the third side. So x plus 15 has to be greater than 20. We're going to have three inequalities. The third side plus 20 has to be greater than 15. And 15 plus 20 has to be greater than x. So x has to be less than 35. So x has to be less than 35. If I subtract 15 over from this first one, so if I subtract 15 over, we get x has to be greater than 5. From the middle one, if I subtract 20 over, x has to be greater than negative 5. Well, which one of these do I pick? I know for sure x has to be less than 35, but x also has to be greater than some number. Well, if I look at negative 5, so let's look at numbers between negative 5 and 5. So let's say 3. Can 3 be a side length? 3 plus 15, is that greater than 20? No, 3 plus 15 is only 18. So you have to pick the larger of the last two values. Let me show you guys a hint on that, or another trick. X less than, take the two sides and subtract them. Take the two sides and add them. So therefore we get 35 and 5. All right, some properties of inequalities. The first one, if A is greater than B and C is greater than D, then if I add C and D to both sides, that still has a true inequality. If A is greater than B and C is some positive number, you can take and multiply C or divide C to both sides and still have a true inequality. But if A is greater than B and C is less than 0, so that's a negative number. Now C is negative, remember you switch the sign. We switched this inequality sign. We switched that inequality sign. If A is greater than B and B is greater than C, so let's look at this one a little bit more in depth. 5 is greater than 3, but 3 is greater than 1. We know 5 has to be greater than 1. That's a true statement. The next part, if A equals B plus C and C is greater than 0, then A has to be greater than B. And similarly, also, A would have to be greater than C, too. So you can pick either one of those. Exterior angle inequality theorem. The measure of an exterior angle of a triangle is greater than the measure of either of its remote interior, than either remote interior angle. So let's look at this, and let's show why. The measure of angle 1 is equal to the measure of angle A plus the measure of angle B. That's our triangle exterior angle theorem. From the inequality properties we just talked about, we then know because measure of angle 1 adds up to be two angles, A and B, angle 1 has to be greater than either angle A, or measure of angle 1 has to be greater than the measure of angle B. Inequalities in one triangle. If one side of a triangle is longer than a second side, then the angle opposite the first is larger than the angle opposite the second. One angle of a triangle is smaller than the second side, then the angle opposite the first is smaller than the angle opposite the second. So what that means is if you have a triangle, and you have a triangle and this is 30, this is 50, let's adjust this a little bit. This is 30, this is 50, they have to add up to 100 or 180, so therefore that's 100. A, B, C. How the length of those sides would go is the length of the side opposite the largest angle is the largest side. So AC is the biggest angle. The largest side. The smallest side would be BC. So BC would be less than. The next side would be AB. Then the last side would be AC. Name the largest angle and the smallest angle for each one of the triangles. So we have to look and see what is the largest side. So the largest side in A would be AC. So the angle opposite of that, angle B, is the largest angle. The smallest side is 15. The angle opposite of that, angle C, is the smallest. Largest and smallest in our second one. Well, X. Then I have 2x, then I have 2x plus 15. So I know if I have an integer value, or any value, if I multiply it by 2, jk has to be greater than x. So the smallest side would be LK, because that's just x. Then because I've multiplied it by 2, the next largest side would be JK. Then the largest side, because I have 2x plus 15, I'm multiplied by 2, then I've added something, is LJ. So the largest angle would be angle K, because that is the angle opposite of that side. The smallest angle would be angle J, the angle that's opposite of angle X. Name the longest and shortest side for each one of those triangles. Well, here we have to find the missing angle. So since the angles in a triangle add up to be 180, so 180, I already have 100 degrees there. Angle H has to be 80 degrees. So my largest angle is angle H. The longest side is opposite of that, so that is GI. The shortest is opposite the smallest angle. The smallest angle is 40, so HI is the smallest side. For the second triangle here, they have to add up to 180. I already have 149. Therefore, angle J is 31. The longest side is opposite the largest angle, so that is JL. The shortest side is opposite the smallest angle. 31 is greater than 29. 29 is the smallest angle, therefore JK is the smallest side. Which segment shown would be the longest? Pictures are not necessarily to scale. So start ranking them. Start with a triangle. We have triangle IJL. This is 75. So I know the largest side in that triangle, or the smallest side, let's start ranking them with the smallest, is, let me move that around a little bit. Triangle ILJ. Our smallest side would be IJ. Then we have the next largest would be, I'm sorry, IL. Then IJ. Then LJ. But then let's look at the other triangle. The other triangle is IJK. They share the common side of IJ. They share the common side of IJ. So I put that right underneath it. And then I rank them. I don't know anything about IK or LJ, but I know this is a right angle. That has to be the biggest angle, or the longest side, because there can't be a 90-degree angle and then an angle that's greater than 90 degrees. So I know this is the largest angle. I don't know the ranking of the other two. I'm not going to put them in, but I know that this is the largest side of that triangle. Since they share the common side, I line them up. This one must be bigger than IJ from triangle ILJ, so LJ is our largest. B, so we have sides parallel. We only have this side parallel to this side. We know this angle's 45 because they have to add up to 180 degrees. So therefore, since I am parallel line, transversal, these angles are equal. This one's 45, and this one then has to be 92. So start ranking them. Triangle FGI. So the largest side is, the smallest side is either FI or GI. Since they're equal because it's an isosceles right triangle, then we have FG. Now let's look at the other side, the other triangle. Triangle GHI. Well, they share GI. GI is the smallest. Then rank, or in triangle GHI, yes, GI would be the smallest. Then I would have GH. Then I would have HI. Thus, HI has to be the largest side. In C, we know 125 has to add up to those remote interior angles, so 2x plus 5. 2x is going to equal 120, x is going to be equal to 60. Therefore, I know this angle's 65, this angle's 60, this one's 55. So now I need the longest side. Look for the largest angle. The largest angle is Q, so it's the side opposite of that, NP. Example 6. List the sides in the figure from shortest to longest. So let's look at one triangle at a time. Triangle ABC. Let's rank those sides. So I know this is the angle B in that triangle is 30. I have a right angle, so the other one has to be 60. My smallest side is AC. The next largest side would be AB. Then the largest side would be CB. Now look at the other triangle, triangle CBD. Well, I have parallel lines. So therefore, this angle here, angle ACB, would have to be congruent. Since this is parallel to this is a transversal, that angle there would also be 60, angle CBD, getting me this angle to be 70. So now let's look at that triangle, triangle CBD. The smallest, well, the side that the two triangles have in common is CB, so I line that up. And I'm always ranking from smallest to largest. So CB, that's technically the smallest side in triangle CBD, since it's opposite angle D, which is the smallest angle. So then I rank next is CD, then the last one, the largest side, would be BD. So ranking these sides from shortest to longest, AC, AB, CB. Now since I've lined up CB and CB, I know my next largest side is CD, and the next one is BD. List the sides of the figure from shortest to longest. Let's fill in our missing angle. Since everything has to add up to 180 in a triangle, that's 45, and this one's 55. So let's look at triangle KLM. Well, in triangle KLM, the smallest side is KM. Then I have KL. Then I have LM. In triangle LMN, the common side that we have is LM, so put that right underneath. Now LM in the other triangle, in triangle LMN, is the smallest side because it's opposite of the smallest angle. So then I rank the next largest side is LN, and our largest side is MN. So I go KM to KL to LM to LN, and then finally MN. Our Hinge theorem. The Hinge theorem says that if two sides of one triangle are congruent to two sides of another triangle, so RS is equal to VW and ST is congruent to WX. But the included side of the first triangle is larger. So angle S, the included angle between the two sides, is larger than angle W. Then the third side of the first triangle is larger. So RT is going to be greater than VX. Our book calls this the side angle side inequality theorem. Side angle side. Side angle side. But another common name of that is the Hinge theorem. So I'm going to be using that. The converse of the Hinge theorem says that if two sides are congruent to two sides of another triangle, so AB is congruent to DE, AC is congruent to DF. Now we talk about the side length. BC is greater than EF. So therefore, the angle A would have to be greater than angle D. So some examples involving that. What can we deduce from the information? So I mark up my diagram. AF is congruent to AB. Angle 1, this angle is greater than angle 2. So I'm going to mark it with 2 arc so that I know 2 is greater than the 1 that I'm going to mark with 2. So what can I deduce? Well, they share the common side of AD. So triangle ABD and triangle AFD share the common side of AD. So I have side, angle, side. Therefore, since 1 is greater than 2, DF is going to be greater than BD. I'm going to erase my markings and do B. 7 is less than 8, so I'm going to mark 7 with 1 mark, 8 with 2, just so that I know 1 is less than 2, so I know where my angles are at. FD is equal to BD. So again, we're looking at triangle ABD and AFD. Well, again, they share the common side of AD. Since 8 is greater than 7, the side AF is going to be greater than side AB. C. FD is equal to DB. But 9 and 8, so this is going to be greater than 7 plus 6. Let me mark that with 1. So angle ADE is larger than ADC. So what I can conclude, since this side is in common, I know that 8 is going to be greater than 7, so I know AE is going to be greater than AC. AE is greater than AC. Our last example. AD is equal to DC. AD is equal to DC. But 6 is greater than 7. So 6 I'm going to mark with 2. 7 I'm going to mark with 1. That's equal. Since 6 is greater than 7, CB is going to be greater than AB. Our last example is a proof. And our given AB is greater than AC. And BD is equal to CE. That's given. So AB is greater, so I'm going to mark it with 2 than AC, which is 1. I'm trying to prove that BE, this side here, is greater than CD. Well, let's look. BE is in that triangle BEC. DC is in triangle BDC. So if I could get, let's break this down, BDC and BCE. Well, I know BC is congruent to BC. From our given, we know BD is equal to EC. If I could get angle B in triangle BDC larger than angle C in triangle ECB, I'm sorry, if I could get angle C, this angle, larger than angle B, then I would have this proven by the Hinge theorem. Well, they give me angle A, or side AB is greater than AC. So I know since since the side that is larger in a triangle, the larger side is opposite of the larger angle. Angle C is going to be greater than, let's name that by 3 letters. angle ACB is greater than angle ABC. So what that means, this angle here is less than that angle there in our smaller triangles. A reason for that, larger side gives larger angle. I know BC is equal to BC by reflexive. Then lastly, I have now our hinge theorem. I have two sides equal, BD equal to EC. I have BC equal to BC, and I have angle ACB. This angle in the red triangle is greater than that angle, so therefore BE is greater than CD by the hinge theorem. So that was a proof and how we use inequalities in triangles. That was a bit long of a lesson, so you do not have a form to fill out. Please make sure these notes are filled out for the due date.